Hi guys, very good afternoon all of you and thanks for joining this webinar. Just confirm are you able to hear me? You can type yes in the chat window. If you are able to hear me, then just type yes. Okay, so we'll start in a couple of seconds. Okay, so once again, welcome all of you guys. So now we'll start with this webinar for MQTT protocol, that is Message Queue Telemetry Transport, and which is one of the popular protocol for Internet of Things. So we'll start our discussion now. So, hi, I am Dheeraj from Axelta System, and I am here as an embedded developer and IoT trainer and corporate trainer. So now we'll start with the webinar. So before starting with the webinar, some few things about our company. So our company is started in around 2013 and we are into IoT education, and we are the world's largest IoT training company, and till now we have trained more than 3,500 professionals worldwide. So we are conducting online trainings and we are also conducting some corporate offline training, uh, India and also abroad, and we are one of the leading company for the IoT trainers. And also along with the IoT educations, we have some IoT related solutions for different industrial and some security domains. So we have some of the clients, these are our some of the training partners. These are the companies where we are official training partners for, say, Intel Germany, Intel India, then Infosys, then Tata Elx and Say Technology. Also, we are providing different solutions for companies like us, Coca-Cola India and Royal Bank of Scotland. And right now, these are the different training offerings we have. So we have around 8 to 9 different IoT related trainings. This is our basic model of training. IoT bootcamp, we are calling as IoT bootcamp. Here we are training the different individual participants worldwide using different technologies like IoT. Then inside IoT, we covering some different technologies like mesh networking, and then some IoT combination protocols and all those things. Then also we are providing corporate training. It can be 1 day or 2 days depending on the projects which we get. Also we have providing offline training in USA. Also, we have just started few months before we started IoT Analytics, which is an online course, 6-day online course, and which is successfully launched. And we have some of the expert trainers for this IoT Analytics. And regarding MQT, we are providing MQT from last 4 or 5 months. We are conducting this MQT training once in a month. It is for 3 days online course and a course plus certification course. Then also along with MQT, we have ThingWorks training. For ThingWorks platform, we have 6 to 5 days of trainings, which is given by certified PTC experts. Also soon we are launching these technologies for school students, and some of the other protocols we are launching soon. These are the profiles of our founders. Those are from IIT background, and they just started this business into IoT education and IoT development. Now, before starting with our journey to MQTT, let's first discuss what is exactly IoT, and then we'll start with the MQTT, where the MQTT comes into IoT, and what are its role and why it is important for in terms of IoT. So you can take any example which we want to make IoT enable. Just a second.
Unmuted.
Yeah, I hope now you are able to hear me. Just confirm me. Okay, Prajwal, we'll just start the IoT. We'll just cover it is in 2 minutes, not the detailed IoT introduction. We'll just cover in 2-3 minutes. Just confirm me whether are you able to hear me, guys? Okay, so basically in just IoT I will cover different keywords which are just required just to make all of us on the same page. So first of all, we have the device or equipment which we want to make as a smart or which we want to make as IoT enable. First thing we need to give it as identity. Identity can be a MAC address, it can be IP address, it can be IPv4, it can be serial number, it can be anything. But generally for Internet of Things, when we want to make it as a publicly unique, then generally in the future we'll see IPv6 will the most popular in terms of identity. Then after identity, we should have the different sensing capabilities to this node. So take example of air conditioner, then depending on the applications or depending on the criteria, we will implement different sensing capabilities into this air conditioner. It can be a detection of temperature, humidity and other power devices. These are from consumer point of view. Also some of the sensors from developer point of view, it can be a detection of leakage or detection of the gas, liquid and all of those things. So this combines a node part in IoT. After that, we generally use a gateway device. This is the device with which we can communicate to internet. So gateway is the one of the device which can talk to several nodes. So assume that in the home you may have one gateway and you may have hundred to thousands in many number of nodes. So which will communicate, the different nodes will communicate to one gateway. This is general architecture. And after that, gateway can talk to cloud system where we have different analytics and different uh, presentations and results which we can have, and then we can have actuation and we can have different data store, all these things. So typically one cloud system can connect to several of the gateway. It can be millions, billions of the gateway. So this is a typical IoT structure. Now in this structure we can say here, this is the node part and this is the gateway. This communication, we can say that this is a short range communication within few of the meter, like 100 meter or 200 of the meter, which can be wired or it can be wireless. So generally we can use Bluetooth or Zigbee or any other technology to make communication between gateway and node. And when it comes to the gateway and cloud, generally we are using existing internet infrastructure, and when we are using this infrastructure, then we have several number of protocols. So MQTT comes over here. MQTT comes into this part, how to communicate over this gateway to cloud or combination of node plus gateway to cloud. We have different protocols. So out of that, one is a MQTT. These are the application domains of IoT. Now we must know all these application areas. Now coming to the architecture of IoT, these are the different protocols which we can use to communicate from gateway to cloud. We can connect the gateway to cloud using GPRS if our application is outdoor. We can use Wi-Fi if it is indoor. Then using this channel, we can use either HTTP as a protocol or we can have several special protocols. So these protocols might be new to you, that is CoAP and MQTT. And why we are using this protocol, why not HTTP? So that we will cover in this coming presentation. So before that, what is exactly mean by protocol, technology and standard? So this is just one slide I put it. So take example of say if you are using Wi-Fi in your mobile phone and you are browsing something. So when your mobile phone talks with the google.com, it you can use a, say assume that you are running a IP as a protocol. It is you have your source address, then you have your destination address as a Google as a IP address. So this IP is the actual protocol at a network layer. Then you might using TCP at a transport layer. Then at application you might using HTTP. So generally for browsing application you might using HTTP at a application level, TCP at a transport level, IP at a network layer. So these are the actually protocols. And to use this protocol you might using any of this technology. So you might using GSMA, CDMA or Wi-Fi technology, and all these technologies are based on any of these standards. So it can be, so generally for Wi-Fi, IEEE 802.11 is the standard which is defined for Wi-Fi, or Wi-Fi is based on these standards. So this is how protocol, technology and standards are linked with each other. So using this definition I can say that protocol is some set of rules at each layer which are designed for communication between two entities, and when we combine these protocols to form a complete stack or complete model, then we can have technology which is a combination of protocols, and all these technologies are based on any of this standard. Now, why MQTT? So now this is the main thing I can say. Like right now, assume that in your home, just tell me in your home right now how many devices are connected to internet at this point of view, or say in this right now what we are running, it's 2017. Generally, maximum 5, 6, or 10 or 8, depends on the how many mobile phones you are using, how many laptops, and how many desktop PC you are using. So generally, less than 10 number of devices are connected to internet right now. But maybe in future there may be hundreds or thousands devices are connected to internet in one home or one house. So assume that in the world, complete world, how many devices will be there? So this is just example of home. If you're talking about the just hospital, then in hospital there may be in one ward there may be thousand number of devices which are connected to internet. In industrial domain, millions of billions of the devices connected to one plant at a time which are connected to internet. So in the future we may have different domains, from transport, from logistics, from security, from industrial, from medical, healthcare. All these devices will be connected to internet. So right now whatever protocols or whatever infrastructure we are using to communicate to internet, which we are using for a mobile phone or laptop, we can't use same kind of protocols or with the same kind of rules. If we are trying to connect to internet, we may connect, but we may have several disadvantage using existing technology. So what are these disadvantages? So first of all, when it comes to IoT device is generally called as a constraint device. So why constant? I will give you one example. So just tell me, you may using laptop or mobile phone, right? So generally, laptop and mobile phone nowadays have same kind of configuration. So generally, what are the configuration of our PC? Say it is a 4 GB RAM, then Intel i7, i3 processor. Then in terms of mobile, it has a high-end processor, 2.4, so 2 gigahertz octa-core processor, and we have 1 TB of hard disk. We have for mobile phone also we have a tera GB of the memory. So we have large number of memory space. We have large number of, say in terms of PC, we have continuous power supply to our PC, laptop. So these devices are full-fledged devices. So mobile phone, laptops are full-fledged devices. So devices which are connected to internet right now are full-fledged devices in terms of memory, in terms of processing, in terms of battery backup, and all those things. But when it comes to the IoT application, we can't put same kind of features to each node. I will give you one example. Just tell me, just to connect your door sensor, you want to detect whether door is open or closed, or just take example of you want to make your tube light to turn on and off remotely. So will you put 4 GB of RAM and Intel i7 processor in it? No, right? Because we want to reduce its price, we want to reduce its size. So we have lot of constraint in terms of IoT. So this slide will tell you what constraint we have. So in terms of power, we generally in IoT devices we have a limited power. uh, so all of you know fitness band, right? So fitness band is just like our watch, wearable watch, which we attach to our hand, which senses for our blood pressure, temperature, and body related things, and which sends data to cloud or IoT platform. So this is one of the example of IoT where we can say, I can say that my fitness band is a IoT devices. But I want to run my watch on small coin cell for 1 year, right? I can't charge my watch like when we are charging our laptop or mobile phone one times in a one day for 2 or 3 hours. But I don't want to charge that much of my fitness band. I want to run it for last for more than 1 month. So same way, these are the constraint. One constraint is it should be battery operated, it should have limited memory, it should have low cost. Then in terms of capability, that is a style of networking, right now Wi-Fi is connected in terms of star. Like we have one router and we have 10 number of laptop connected to one router. But in terms of IoT, if we have thousands of hundred number of nodes, then we want some special kind of networking style. It may be mesh, it can be some of the complex technology which we want. So one thing I want is it should be mesh capable, it should be limited memory. Then it's also, it says that it should be secure, it should be scalable, it should be addressable. So to achieve this, how we can achieve this? The protocol design, how we have designed the protocol should be lightweight, should be a small footprint, and so footprint and memory footprint should be small. So I am saying that footprint is small. It means the number of bytes consumed by that device is less. So like in your, say in your case of laptop or PC, generally we require 4 GB of RAM to run a Windows 10 or Windows 8, right? So but we don't want to run that kind of complex operating system, so my footprint should be small. So the size occupied by my code should be small, and these are the constraints. So how we are achieving this constraint using MQTT is due to this point. So these are some of the few points. We'll cover more points in the coming slide. So one is low bandwidth, low power protocol. So MQTT is a low bandwidth protocol. So when you are sending a packet using MQTT protocol, the number of packet size carried, the number of the bandwidth utilized by this protocol is very low compared to other protocols. So it is a low bandwidth, also it consumes a low power. Second thing, it is a two-way communication. So generally for our HTTP protocol, we have only one-way communication. There is only server and client, only request and response. So always client need to query from the server to get. So it is a two-way communication. We can have two-way communication using MQTT. And this is the one of the point, publish and subscribe. So MQTT architecture is based on publish subscribe model. So what is meant by publish subscribe? So that I will cover in detail when we go to the architecture of MQTT. But right now you just make note of MQTT main or major keyword related to MQTT is publish and subscribe. So Piyush is saying ThingWorks we are using duplex. So yes, Piyush, but in ThingWorks we are not using HTTP. There we are using always on protocol, which is based on WebSocket. So WebSocket is one of the two-way communication, but it is not a low bandwidth protocol. It is consuming a lot of bandwidth or a lot of memory if you are using the existing protocol, same as our WebSocket. Then data agnostic. So payload agnostic, data agnostic, it means in MQTT while sending a packet, we no need to define the type of data. It doesn't carry the kind of data packet it has. Like in HTTP, we always need to specify whether it is a XML or whether it is JSON format or whether it is a HTML, or there are many number of formats are there. But in MQTT there is no data format. Data is just a binary data. Whatever data is there, it will act as a just a binary data when we are communicating with devices. There are also other features. You can just read this slide, and also we are covering this in coming further slide. So it is a firewall friendly, and we have some authentication and some of the security features, and large ecosystem means we have a lot of uh, I can say the support from different, as it is an open protocol, we have different support from different experts to build our ecosystem based on MQTT. Then these are the key feature of MQTT. First is it open, and it is as we know from software background, all those technology these are open source. Like in terms of Linux, it is open source. That's why it is more popular in terms of server industry, right? Same way MQTT is open source. So we just need to refer the specifications of MQTT, and you can build your own MQTT protocol using any language, runs on any hardware. So there is no any proprietary language or proprietary company which design this protocol. You can build your own protocol using any language and using any of the platform. Then it is reliable. So reliable, why it is reliable? Because we have several features inside the MQTT. One is the quality of service, and second is some of the features like last will and testament. So as we have the limited time, so I am not covering that into details, but just as a time being, quality of service is one of the feature which defines with what reliability you want the message to be delivered to your destination. So as you are going to more and more quality of service, we have three levels of quality of service: 0, 1 and 2. If you are increasing your quality of services, it means you are making it more reliable in terms of delivery. Then it is a lean. So lean means minimum wire format. So smallest packet size is just a 2 byte. So assume that you just want to send a few bytes of information. So if your application is a very few, so smallest number of packet in terms of MQTT is just a 2 bytes of the packet, and this is the footprint. So if you are building your protocol using C language, then you just need 30 kilobytes of the memory space or a flash memory to run this protocol. I will give you example, like if you want to build say complete Microsoft operating system, so generally you will utilize generally 4 GB of hard disk to build your operating system, right? So that's why they give some minimum number of address space which required in terms of hard disk to get installed that system in your machine. Same way, if you want to run your MQTT protocol, if you want to build your MQTT protocol, if you are building that protocol into in C language, then you just need 30 kilobytes of memory, and if you are using Java, then you are just need 100 kilobytes of memory. One of the feature like is simple minimum headers, asynchronous, and all these features are there. Then how MQT is started is actually MQT is started more than 10 years before. There was one project from one of there was one project, and this MQT is designed by IBM in combination of IBM and Eurotech, and they were having some requirements to sense the leakage of this pipeline and just to give that information to their SCADA system. There they can have maintenance and billing department. So for these projects they actually started building some protocol which will be lightweight, and they can communicate to several number of nodes, and they can get this data. So while building this protocol, while building this project, they design actually this MQTT protocol. After that it was not that popular in terms of the industry, but due to its features, nowadays from last 3 years it is getting popular for IoT application. So this is how actually this is the origin of MQT. It is started with, it is designed by these two authors, Dr. Andy and this Nipper from Eurotech and IBM. They started as a closed project. After it became an open standard in 2004, they given it to MQT org. Then they given it to Eclipse PAHO projects, and from 2013 now it is managed by OIC standard, which is a technical committee which is taking responsibility of this MQT. So right now who are using the MQT? So these are the some of the projects which are currently running. So it may be new to you. You can just refer to a website and you can go. So these are the existing projects from IBM which are currently using MQT. Also there are several IoT platform, several popular IoT platform like even ThingWorks is there, then Microsoft Azure platform, then Amazon Web Services, IBM Bluemix. So these are the platform, most top platform. They support this protocol, that is the MQTT protocols, to connect their things. One of the popular example from our young generation is a Facebook Messenger. So Facebook Messenger actually uses a MQTT protocol for their communication. So initially they were facing some issue with battery backup when actually Facebook Messenger launched, but later they designed their complete messenger based on MQTT protocol. So this is one of the example, I can say real life example, which we are using as a all individual which we are using. So same way we might have many other applications which we are not aware, but right now there are several companies which are already started using this protocol. Now this is one of the popular slide. Also guys, this MQT protocol, you might heard this term MQT first time in your life. Maybe from last 1 year only you are hearing this word as MQT protocol if you are doing something related to IoT, or if you want to make your career in IoT. But trust me, this is one of the protocol which is required as a key essential or a key skill set required from most of the companies when we apply for the job in IoT. Yeah, Piyush, we ThinkWorks also supports the MQT. Even in Axelta, we have ThinkWorks as a training, full 6 days course. In that, we have one of the day where we'll show you how we can interface this MQT in ThinkWorks. I think Piyush, you are from that participant, right? ThinkWorks. So you will surely learn that how to use that MQT protocol in ThinkWorks. So what I was talking about in terms of the job or in terms of career, this is one of the popular protocol. Whether you are from software background or MCA background or computer science, or whether you are from hardware, that is electronics or embedded domain, you always need this essential of MQT. Why? Because assume that you are building a embedded device which you want to make as a MQT enable, then you should know what are the features which are there, how we can use that API to build MQT. And if you are into software, then when if you are as a software developer, then you should know how to develop this protocol, how we can modify this protocol, and how actually using the language this protocol is designed. So this is one of the popular difference, or this is one of the thing which you should keep in your mind, that when we compare HTTP, this is one of the popular protocol for web application. If we are comparing this HTTP protocol with MQT, then these are the differences. And why we are comparing with HTTP is because right now the world is most internet are based on HTTP only. So right now we are using internet in 99% internet we are using in the laptop and mobile phones only, and for all our tasks, it can be watching the YouTube video, or it can be browsing, it can be downloading, it can be Skype, anything which we currently running as a web application. Most popular protocol is HTTP for all web application. And how we can compare this with MQT is, first of all, HTTP is asynchronous. It is based on the request response, whereas MQT is asynchronous. It is based on event driven. So it may be just you can say it is just A is added to synchronous, but it is one of the major difference between, or one of the advantage in terms of IoT. Why? Because asynchronous means there you no need a continuous connection between server and client. When assume that you are browsing the internet, if Google server is not there, it's not available, you will get the message that server is not available. Or in terms of client is not available, then server will fail to send message to client. Same, it is synchronous means there should be continuous session. So there should be continuous session awareness required for HTTP protocol. But in terms of MQT, it is asynchronous. Even your client is not available, once it come back, it will receive that message. So there are some features with that we also receive the message even though we are offline. So this is one of the asynchronous, that's why we are calling it as a asynchronous protocol. Enough secure as HTTP. So security depends on the whatever features you are utilize uh, in MQT, Rakesh. Actually, in the both protocol, when it's come to security, security is managed by transport layer. So when it's talking about HTTPS, so HTTPS is based on TSSN and SSL. So those are transport layer security, and HTTP is application protocol. Same way, MQT also has same kind of stack. So I can say that both are having same kind of security, and it depends on the transport layer and network layer. Then so this is application point. So in application point, we are using HTTP for web browsers and MQT for machine to machine or IoT application. Message size, so when we are sending a message, it is having rich header, and it is just 2 bytes of minimum header. So header means so I hope you are aware of the headers. I will give you a small example. If you want to post a letter to your friend, that is a postcard, then along with the actual message, say you have written the message, hi Rakesh, how are you? So along with the message, you attach that your message into envelope. Then in the envelope you write your address, then you write the address of your friend, their address, then pin code number, mobile phone number. Then it goes to the postal department, they attach their stamp and the stickers and all those things. So these are the extra redundant information which are required to get the information to delivered. So this we are calling as a headers. So in HTTP we have rich headers, means header size is very large, but in MQTT we have small number of headers. Then we have several other difference. I can say, you can just read this slide. In terms of HTTP, we can have mechanism from client to server push. So client can push to server using HTTP also, MQTT also, but pushing from server to client is not available in HTTP. This is one of the major drawback of HTTP is, assume that you are connected to your wearable watch to one of the IoT platform, and if you are using HTTP protocol in between these two, and suppose server wants to send any data to client, then he cannot directly send data. Always client need to make a GET request. It's called as a polling. So polling has to be used on top of HTTP to make the push from server to client, but it is by default available in MQTT. In MQTT, directly push mechanism is available where server can directly push message to client. Then standard, it is made by OSS, and this is one of the major difference is data distribution. Generally in HTTP we have only one-to-one. We have one client, one server. There can be millions number of clients connected to Google server, but communication between each one of them, it is one-to-one. So one server, one client. But in MQTT we can have one-to-one, that is a one server, one client. Then we can have end-to-end, end-to-many, one-to-many. What it means, it will cover, it will more clear when I will go to the next slide. It means different clients can communicate to different client through server. So we can have one-to-many or many-to-many or many-to-one kind of communication. So this is one of the real life difference between HTTP and MQTT is that if you are sending a single piece of data to HTTP server, sorry, if you are getting a data, then generally for HTTP you need 300 bytes to get the data, but in MQTT you just need less than 4 times of the data bytes. Same way for putting, it is almost 7 times less than compared to HTTP. So generally I can say that it is a 7 to 5 times compact in terms of packet size comparing to HTTP. So when you are sending some actual information, if you are using HTTP, then whatever data bytes you required compared to MQTT, you required less than 5 or 7 times of data or the number of the packets compared to HTTP in terms of MQTT. Now, before going to the protocol stack layer of MQTT, this is OSI structure, and I hope most of us, you are aware of this stack is. So this is the OSI stack, OSI layer, which is a reference model for all the protocols or all the technologies, and based on this stack we can have TCP/IP stack. So right now, say example Wi-Fi is based on TCP/IP stack. So at a transport layer you are using IP, sorry, at a network layer you are using IP, at transport layer you are using TCP or UDP, and at application layer you can have different choice from HTTP and HTTPS and many other protocols. So right now for all web application, or for right now whatever infrastructure of internet which is already there is using TCP/IP stack. So now where to put MQTT over here? So that I will show you in the next slide. So before that, this is one of the slide which I have put just to make aware. In terms of HTTP, we have client and we have server, and HTTP as a application protocol, that is HTTP which is running at the application layer. Between this protocol, between this client and server, this is a general communication or general handshaking is happening between this HTTP protocol, and we have different methods: get, post, put, and delete. But when it comes to MQTT protocol, so as I told you, MQTT is one of the application layer protocol. So same way I shown you TCP/IP stack. So in the top layer, which is at application layer, it comes. So MQTT comes at a top layer at application level. Just below MQTT we have TCP, and just below TCP we have IP. So this point, maybe this is one of the question asked in terms of your interview, that which is the transport layer protocol which is supported by MQTT is a TCP. So we can have choice of UDP and TCP, but MQTT uses TCP. So TCP is the transport layer protocol which is running at a transport layer, and on the top of this TCP IP we have MQTT. So when it comes to this architecture, if we have client and if we have the server, And why it is called as a broker, that I will cover you. So if we have client and broker, then in between these two, this is the MQTT layer, which is application layer, and just below this MQTT we have same. We have TCP and we have IP and we have some hardware layer protocol, same as our existing TCP IP stack. So that's why you can use this MQTT protocol which supports the TCP IP stack. It can be a Wi-Fi module, it can be Ethernet based. So whatever hardware, embedded hardware you are using, we just have to import the specification or the library or the protocol term of MQTT, which will add as the library, and on the top of the TCP IP we are running this MQTT as a protocol. So Rakesh is asking MQTT is a connection level while TCP is a. So guys, maybe I will hold all your question. I will try to answer all your question in the last 5 minutes, as we have limited time and I need to cover many of the features. So MQTT specification is a list of some standard set of rules. So using this rule, actually you will build your protocol. So if you are a software developer, then you will actually use the specification to build your protocol. And right now the latest version of MQTT is a MQTT version 3.1. So you can refer this specification, it is open source. So you can directly go to OSS website or mqtt.org, there you will get the specification, and using this specification you can build your own protocol using any language. So this is the architecture. HTTP is a connectionless. Okay, I will give this answer right now only. So MQTT is a connectionless via TCP. So Rakesh, connectionless and connection oriented is not dependent on the application protocol, it depends on transport layer. So at transport layer, if you are using TCP, it is a connection oriented, and if you are using UDP, it is a connectionless. So as MQTT uses TCP, it is a connection based or connection oriented, and in terms of HTTP, if you are using TCP, then it is a connection based. If you are using UDP, then it is connection less. So it depends on the transport layer protocol. It not depends on MQTT or HTTP. Connection less or connection oriented, it depends on transport layer protocol. It is not based on application layer protocol. Now, in terms of architecture of MQTT, we have broker. So what is broker? So broker is one of the thing which is acting as a server to having the communication between these clients. So this is a typical architecture of MQTT, and it is, as I told you, it is based on publish and subscribe. So publish and subscribe means the clients which will send a data to broker, we are calling it as a publisher, or the process we are calling as a publish, and when broker sends data to client, it's called as a subscription. So assume that say take example of Amazon, if you want to get some t-shirt, if you ordering some t-shirt from Amazon, then finally that t-shirt we are getting from any of the shop, right? So that shop which is actually selling that product to Amazon is acting as a publisher, which actually publish that t-shirt to Amazon, and you are as a subscriber, you are getting that t-shirt from Amazon. So broker is acting as a middle agent, which are actually filtering these different clients, and we can have several number of publisher and we can have several number of publisher. So any client can act as a publisher, subscriber, or both. So if we are receiving a data from broker, we are subscriber, and if we are sending a data to broker, we are a publisher. Now how to publish and how to subscribe. So to publish anything to broker, we need to define two things. One is a data and one is a topic with which we are publishing. Say take example of your home automation. Assume that in home, if you have deployed of 5 sensors, temperature, humidity and light, then each sensor will have data like 25 degree, 33 as a humidity, and the light as a 30 lux. So that is actually data. So data is a payload and topic is it can be any name. So assume that your sensor is publishing a data to broker, it will publish with a topic as a temperature and data as a 25 degree. And if any client is interested to get that data, it will just subscribe to that topic. So it will subscribe to topic temperature and it will receive the 25 degree as a data. So this publisher is my sensor and subscriber is my any client, and broker is a broker. If I am publishing a 25 degree with topic name as a temperature, if I am interested to get the data, I will subscribe with topic name as a temperature, I will receive the 25 degree. So this is just one of the example if how publish and subscribe work in MQT. So there is no request and response, like there is no in generally in HTTP we have publish sorry, we have methods like get, post, put, delete, then we have request and response. But in MQT we just have topic, we have publish, we have payload, we have subscribe. Then as I told you, it can be, there can be many publisher, there can be many subscriber. So assume that there is a one publisher, then there can be hundreds number of subscriber which are receiving the data, or there can be 100 publisher which are publishing simultaneously, and there can be 100 number of subscriber which are receiving simultaneously. So this is one of the example which we can have. So same now this is one of the core advantage of MQT is that we are calling it as generally as a decoupling. So just a second guys, I think. Yeah, so we are calling it as a space decoupling, synchronous decoupling, and time decoupling. It means the publisher and subscriber, they no need to know each other. So publisher can be placed anywhere. It can publishing at any time, say it publishing at a 10 a.m. in morning, and any subscriber can receive that data in 11 a.m. is possible. So they know they are decoupled in terms of time, in terms of space. Also they no need to continuously make connection to broker simultaneously. Assume that at a time only one client is connected there. After 12 p.m. there may be 10 number of clients connected. So connection can be at anytime any clients can connect to at any time. So there is always decoupling in terms of space, time, and synchronization. So I will just give you one example. Topic I told you, one topic I told you, that is the temperature. But generally in terms of topic, we can have different hierarchy levels. So take example of your home automation. Then as I told you, in the future there might be 100 number of nodes in the one room or one home. In one floor there may be 5 flats. In the one building there can be it can be 50 floors of building. So I assume that we can have different wings. So we can have this hierarchy while publishing. So like in your home, if you are publishing a temperature, then you can attach a building name, that is building A, then floor 1, room 1, and temperature. So why we are attaching this hierarchy is because suppose if any client is interested to get a sensor data of all the building, he can subscribe. If he is interested to get all sensor data of only first floor, he can get that. If he is interested to get only first floor data but only building A, it can be possible. How it is possible? Because there is a concept of wildcard. So this wildcard is actually a matching directory you need to pass while subscribing. And guys, as we have only limited time, I am just covering the different terminologies which are there as a key features of MQT. I am covering. I know it is not easy to cover all the features of MQT in just a 1 hour. So what is this exactly topic hierarchy, and what is exactly mean by wildcard? You may not getting it exactly, but my aim over here is just to cover different terminology and what are there exactly. You may refer to this after the presentation. But using this wildcard entry or wildcard mask, you can filter different topics. Say there we can attach this plus and hash symbol. Assume that this is my published topic, building A, floor 1, room 1, and temperature. And if I want to get this data, I will subscribe to same. I will subscribe to building A, floor 1, room 1, temperature. Then I will get this data. But if I am interested to get all the data of all the building, all the floor, all the room, all the sensor, then I will just subscribe to hash. If I am subscribing to hash, I will get all the data. If I'm interested to building a data only, then I will subscribe building a hash. So I will get data of all the sensor, all the floor, all the room, but only building A. And using plus symbol, you can match intermediate directory. So this is also possible with this wildcard. Then I was talking about the quality of service. So quality of service, as we are moving to different quality of services, we are becoming more reliable. So what is exactly mean by reliability is it's not that as we have limited time, but is this is just an image you can refer. It depends on the handshaking. In the quality of service 0, we just have one level of handshaking. That's why we are calling it as at most once delivery. So this is one of the default quality of service. If we want to move a more reliable, then we can have uh, handshaking to just check whether my message is delivered or not. So if we have one level of handshaking, we have quality of service 1. We are calling it as a at least once delivery. And if we are also increasing some more handshaking, then it's called as exactly one delivery. So this is, as we are growing to more and more quality of services, we are becoming more reliable. Now, assume that now you are as a IoT architecture, you got the job as IoT architecture and you got a task to build an application which will connect the thing and which will make your IoT system, which will have MQTT protocol. Then what things you required is, this is the slide. This is I'm saying it as an ecosystem. So first of all, you need a MQTT specification. So MQTT specification means the set of rules, or actually a protocol or the library. Then you need a MQTT broker. Obviously, you need a broker. Then you need a client which will actually publish and subscribe. Then what is client? So client can be your mobile phone, it can be PC, it can be home, it can be browser, it can be embedded device, like it can be Raspberry Pi, it can be a Wi-Fi module, it can be Arduino board. So those who are from embedded background, they know all this, what is exactly mean by embedded device. So it can be, so your client can be any device out of this. It can be mobile phone or any hardware device. Then you need a broker, you need client libraries. So client libraries means, assume that I want to make my this Arduino board as the MQTT protocol enable, then I need to import that client library in this hardware because I want this hardware to make aware of this protocol. That's why I need these client libraries. Then client application means your actual application. Actual application means, assume that if your temperature is 25 degree, then you want to publish that, or you want to switch off your fan if you are receiving a subscription message as off, if you want to switch on it if you are receiving messages on. So which is your actually client application. So application which is running actually to make your thing to work as per your requirement. Client library is a thing which will make your hardware to make aware MQTT protocol using this specification. You need broker and you need a publisher and subscriber. These are the some of the features of MQTT protocol. As we are not covering this in details, so we have these features. Out of that, I just told you what is public subscribing and what is decoupling and what is topic and how to use quality of service and wildcard. We have several other features like keep alive, then retain, then last will and test. LWT means last will and testament, then how to put username and password, what is mean by clean session and persistent session. So all these are the features of MQTT actually. So uh, these are the features which are the part of that protocol, and we have to use these features to make our system to run as per our my requirements. These are the features. And when it comes to development and API, then we can have different. We already have some of the clients from different languages. We have several clients which are already there from C, C++, .NET and Java, JavaScript, Python and all other languages which are open source and which are already available from Eclipse, PAHO projects or any other vendors. And also we have different, and these features which I was talking about, whether these features are supported by that implementation is or not, it depends on that implementation. There are some implementation which only supports quality of service 0. There are some implementation which doesn't support this last run testament and return. So it depends on the purchase capability of you, or depends on the requirement, depends on the hardware, whether that features are supported by that or not. It depends on their implementation. Eclipse, PAHO, you can just go to this website So already Eclipse Paho has already developed some of the MQT clients which are already there, which are running on C, C++, on Java and other languages, Lua script or Python and other scripting language are already there. When it comes to broker, so broker, as I told you, broker is acting as a server. So there are already some open source and commercial broker available from different companies like IBM, Datasphere and DigiSquare. Also there are some RabbitMQ and then HiveMQ and Mosquito. These are some of the popular open source broker you can directly download in install in your machine. If you are downloading that software and if you are installing that machine, if you are installing that package in your PC will act as a broker, or you can uh, download that broker in your Raspberry Pi, then your Raspberry Pi will act as a broker. So it depends on the hardware structure. So these are the some of the brokers. Just as a slide, it's just for your reference purpose. So just you can go to you can search, and there are some brokers which are open source, which are commercial, and depends on the your requirement. Like some brokers are the commercial, and why commercial? Because they provides more features. As I told you, it's one-to-one protocol or one-to-many. I told you previously that it can connect 100 number of clients to one broker. It can connect thousands of million. When I'm saying it can connect to 1,000 or 100, it depends on the broker capability. So there are some broker which can connect only hundreds of the clients. So depends on their capability whether we are going to purchase that broker. So depends on your hardware capability you can have. And this is if you are comparing this broker, then I can say that whether that broker supports the quality of service 0 or not, whether there are some also special features like bridging, clustering, then the security SSA and TSS and clustering, WebSocket. So these are the special features. We are not covering that into details, but whether these features are supported by these brokers or not, this is one of the slide. Depends on the broker capability. It may support or it may not support. And this is the just slide I added just to show you what is exactly mean by control packet. So when I'm saying that actually my packet is flowing in wire, so there are 14 number of packets. So these are the packets. It like some packets are required from connection point of view, some packets from subscription point of view, and some from publish point of view. So these are the packets. So you can actually in the our course which we have as MQT course, we are covering this complete packet structure in details. But right now I'm just giving you as a just introduction what are the different packets available to you. Now this is one of the important slide I just added just as your reference. So right now you are using internet in your mobile phone and laptop, right? So this is the actually stack which is right now running in your machine. Assume that you are using Ethernet, then this is a Ethernet based on this standard. Then sorry, this is the web stack. Then assume that you are using Ethernet as connects to internet. You might using Wi-Fi as a hardware, Ethernet or Wi-Fi. Then you are using IPv4. At transport you are using TCP/IP. At application you are mostly using HTTP, and generally your data format which is actually you are supported by your browser is HTML or XML. So when you are browsing google.com, you are receiving message in XML format, and typically you are running the web application. So this is a stack which is right now running in your machine as a web stack. But when it comes to IoT stack, how I can compare this with this is that mostly we are using IEEE 802.15.4, which is a low power mesh for hardware related things. And mostly in terms of IP, we are using IPv6 mostly. And compared to TCP and UDP, we may use TCP or UDP, depends on application. And here, so instead of HTTP and other protocol, mostly you are using MQTT. Also, we have several protocols like CoAP and XMPP and MQP. Then compared to your XML and HTML format, assume that your fridge is connected to internet, or your dog connected to internet, or your watch is connected to internet, or your tube light is connected to internet. So they will not browse anything. They don't want data in form of XML or HTML. This format is there for human representation purpose. We want data just as a data. So that's why in terms of IoT, data format is just binary or JSON format. And typically application running for IoT is IoT application compared to web application. So this is how we can compare complete stack in terms of web stack. So this is how MQT comes into picture. So MQT comes over here, and also we have other protocols. Hello, I think.
Muted.
Hello, are you guys able to hear me? Okay. So thank you guys. I think we are at the end of our session. So I was talking about this tag, then I just moved to this part. So this is the course which is given by Axelta. So we have a complete 3 days MQT training, including hardware practicals and including training, theory training. And actually we are having 4 day each session, 3 days, 4 hours each day. And in each day we have 2 hours of theory and 2 hours of practical. So generally, we are shipping this hardware kit and we are covering this number of topics, and this of number of 8 to 10, 9 to 10 practicals we have. Also, we are taking a complete use case which covers complete use case of MQT. So you can enroll for this course. So this is complete 3 days course, online training plus certification course. Now just take me some of the question, guys. Yeah, Akshay, client can use MQT and HTTP both. So like there are several actually that we are covering in this our practical course, that we have several tools which are already available from Google Chrome and many other browsers which supports the MQT plus HTTP. Right now your Google Chrome supports the HTTP protocol, right, for browsing application. Even your Google Chrome can supports MQT protocol, but you need to download some extension. So any clients or any embedded device or any hardware, anything can have a different protocols for different communication. It can have HTTP plus MQT or combination of both or any one. So clients can use both. So I think we are at the end of session. Just a second, let me give any other questions. Yeah, Akshay, server can also have both, but generally for in terms of MQT, we are it's calling as a broker. So if you're taking about, say, take example of ThingWorks platform, then ThingWorks platform, when I say it supports the MQT protocol, it means first of all we need to connect the ThingWorks platform to any of the broker which has capability of the MQT connection management. So server also can have different protocols, and client also have different protocols. So thank you guys, thanks for your attention, and these are the different training offerings from Excelta. So you can register to any of this course, and particularly when it comes to the MQT, as I told you, this is very nice hands-on session given by Excelta along with the hardware kit, and we are covering a complete use case along with different hardwares and along with the different theory and practical topics. So thank you guys. Thanks for the such great comments. So I think it's 6 p.m. So now I will just close the session. Thanks for your attention. Thank you guys.